Bonjour tout le monde, mon nom c'est Nicolas Benoît de la Commission géologique du Canada. Je suis co-leader avec Josué Jotti du projet intitulé Reconstructing Long-Term Environmental Records to Support Regional Assessment. The project is located in the region of Ring of Fire in Ontario. The Ring of Fire is a region with large deposit of nickel, copper, zinc, chromium, and platinum group of mineral. It is located in one of the world's largest peatland systems sensitive to climate change and anthropogenic stresses. Due to its expected development in the next decade, additional knowledge is required in order to understand the potential cumulative effect of ongoing future climate change and anthropogenic stresses. The natural presence and behavior of metal in this environmental system needs to be carefully assessed prior to any development. Because of the sensitivity of the system, changes to groundwater flow dynamic, changes in lake sediment conditions, and forest fires can potentially enhance the remobilization of metals over time. Therefore, it becomes important to explore and develop new environmental indicators adapted to the Ring of Fire environment. It is a multidisciplinary and multi-institutional project that combines hydrogeology, geochemistry, and dendrochronology, among others, with about 20 scientists and technical experts. Collaboration with provincial agencies and with the industry is under discussion. Our main objective is to increase the knowledge of the evolution of wetlands environmental basin conditions in a response to climatic and anthropogenic stresses and its effect on metals mobility. This project activities will extend over 3 years and focus on determine geoscience baseline conditions, characterize regional hydrogeology, and conduct paleo-environmental reconstruction. And in the case where the COVID-19 situation continues to restrain travels to the north, an alternative analog site that is more accessible will be sampled instead. This year, we focus on compiling existing geoscientific knowledge on the region. In the next few slides, I will present some of the geoscientific information that we currently have on the region. The Ring of Fire study area is located approximately 500 kilometers northeast of Thunder Bay and is composed of a majority of wetlands, which represent 99% of the territory. 2 First Nation communities are located within the extent of the study area, and 3 others are located less than 50 kilometers from this map. Concerns have been raised by some of these communities with respect to the environmental impact that the future mining development might have on their traditional lands. This project is part of the regional assessment and will involve consultation and engagement of this community. The topography of the region is relatively flat with a very low regional gradient where elevation range from sea level at the James Bay to a maximum of around 250 meters in the west. Regionally, the elevation decreases along the Attawapiskat River to its outlet in James Bay. The local topographic height seems associated to glacial deposits such as Still and Esker and could be preferential recharge area. The compiled bedrock map clearly shows 2 different geological settings: the Paleozoic sedimentary rocks of the Hudson Bay lowlands to the east and the Precambrian rocks to the west. The limit of these 2 contexts is here on the map. Then we define 2 zones, one for each geological context. These zones are centered around the Victor mine, just here, and around the Neuron project mine here. These zones are currently under more detailed investigation by our team due to a better data coverage or availability for hydrogeology The following is a compilation of surficial geology mapping produced by the Ontario Geological Survey, covered by maps of different scales or resolution. Overall, the surficial geology is mostly composed of organic deposits in gray color, corresponding to wetlands, and by glacial sediments such as teal in green to the west. Locally, glacial deposits in orange are observed, particularly an esker along the Muktai River near to Noron exploration site. Based on the actual compiled data, the average thickness of the unconsolidated sediments is about 11 meters, with a maximum thickness of 127 meters. At the moment, we compile a total of more than 1,800 boreholes, shown in green, and more than 200 wells in red. In addition, there are 249 outcrops extracted from geological maps. The first map produced with this data is the spatial distribution of sediment thickness. Because of the locally clustered and sparse data, we need to use a regional correlated auxiliary variable, the topography in this case, to obtain estimation of the sediment thickness shown here. On this map, it is very interesting to observe a strong thickness contrast between the sediments overlying the shield and the lowland rock zone. This is something to dig. This regional map can be updated with the upcoming data, and it is useful to provide regional cross-sections to help to precise the groundwater and surface water interaction and eventually develop a regional model. For the hydrogeology component of the project, we need to complete the validation of compiled existing data, and additional data is required. There are no provincial monitoring wells in the region, thus data from Noron studies and Victor Mine are then crucial for the hydrogeology perspective. Later review show that drawdown in Paleozoic bedrock likely affects the water level in the wetlands. The case study of the Victor Mine show an impact of the drawdown up to 6 kilometers away from the pit. The drawdown is influenced by the massive bioworms acting as piping connecting the surficial environment and the groundwater. There is a lack of knowledge regarding the groundwater-surface water interaction in the shield bedrock area. Also, the hydraulic role of regional faults in Noron sector is not clear, as well as the permeability of the watershed shield bedrock. The ongoing work will allow us to develop a conceptual model of the groundwater-surface water interaction in both shield and Paleozoic settings. Taking advantage of a large datasets of elemental concentrations in lake water and lake sediments, we have been doing some preliminary investigation on available geochemistry data from the province of Ontario. The database includes parameters for more than 1,000 lakes in the Noron area. We have been conducting some reconnaissance mapping revealing anomalous lakes as illustrated on this map. Here, high electric conductivity values of surface water could be an indicator of an influx of highly mineralized groundwater. Comparison and evolution of metal concentration in lake water is ongoing to provide preliminary insight into the distribution of sensitive metals such as chromium. This work on metal concentration is also ongoing for lake sediments, where preliminary investigation in this area reveals that lead has seen an increase in deposition since the onset of industrialization. It shows that contaminant might have already reached the ring of fire area via long-range transport and should be considered when evaluating the sensitivity of this environmental system. Ongoing exploration of geochemistry data will help later to define the best sampling sites. In conclusion, the existing data collected so far has been integrated in the GIS and associated database, and we hope to collect more data, in particular for those from Noron studies and Victor Mine. Indeed, more data is needed to provide a regional hydrogeological conceptual model of the study area and also to improve understanding of metals of concern, such as chromium. The example of the lead concentration in lake sediments shows that the geochemistry can help to provide insight on the long-term evolution of metals in this environment. With the analysis and the synthesis of the current geoscience knowledge, we are in the process to identify gaps and targets for fieldworks planned next summer. Thank you.